First of all, you're all aware of the cliche of community, economy and environment. We've got to have the triple bottom line. I prefer to use the words folk, work and place, which is a Patrick Geddes thinking tool, which shows that there's nothing new, and especially not issues of sustainability. They go back as long as town planning itself. And what we do in Gaia is we've broken these down into 6 key principles, dealing with healthy environments and communities, dealing with effective use of resource, within which is materials, water, energy, etc. That's the one people tend to focus on most. Managing the approach, which is all the badging and the BREEAMs and the eco-labels and all the rest of it. Minimising pollution and enhancing biodiversity. And whenever we're looking at projects, we look at all these 6 areas. So it's really making the point that this obsession with the carbon atom is actually to the detriment of all the other issues we need to be dealing with on a way in which we're living on 3 planets instead of 1, and we've actually only got 1 available. So if we're going to actually live sensibly with our environment, then we do have to look at the holistic process and not think that if we resolve the carbon issue, then suddenly with one leap our hero is free. I have a little theory that the carbon trust will within 10 years be the methane trust, and after that it'll be the healthy indoor climate trust. In terms of European backdrop, we have a very interesting context where they're wanting to make sure that all new build houses within the EU will have to fulfil strict energy saving goals from 2020 on. The building sector within the EU consumes roughly 40%. That's always the same as the UK. And the Parliament originally wanted to allow only zero energy dwellings from the end of 2018, as planned in the UK. The other EU states, however, were opposing such strict regulation. The German building industry called this a death sentence for the building industry. And what's quite interesting is this is all related to the fact that everybody sees that the ecological design, the green building design agenda will cost more money. Now, I refer you to chapter 6 in this book, which actually shows case study after case study after case study where it doesn't have to cost more. Those who do not learn from history are doomed to repeat it. So we have Stuart Milne coming along with their eco-blung house 2 years ago, and I said to them, please don't do this because you'll find it actually won't do what you want, and it's going to cost a lot of money. Basically what you're doing is you're spending 6 grand on turbines, 3,000 on thermal collectors, 12 grand on photovoltaics, 21 grand, payback 100 years, life expectancy 20 years. And because 90% of conservatories have heating systems put in them, sociology will always beat technology. Then if you put a greenhouse on the side of your building, you will never get your money back, ever. So what do? Plan B? Well, my suggestion, even then, 2 years ago, was can we just wipe all that off and start again and put in 300 mil insulation, do some air tightness, build it and test it, 8,000 quid, payback 5 years, life expectancy 50 years. Factor 9, a third of the cost, 3 times more effective. Now, this is work by Peter Warm on some housing in Cornwall, and he does a fantastic job on crunching the numbers. And what he's doing is looking at the difference between the capital cost in terms of the pounds per tonne of CO2 invested in whatever technology you're making, and the revenue saving in terms of the percentage of CO2 that's saved. So the blue versus the grey, you'll see there's some good bung for your buck and some bad. And what he's doing is saying, before you decide you're going to have your air-to-air heat pump or your CHP plant or whatever, why not look at the numbers for each of those technologies for this particular project in that particular site with those particular clients? And what they found here was that if you went for microturbines, then the blue is what you invest and the red is what you get back. If on the other hand you stick your turbine where it does its best work, then you invest 2/3 of the carbon capital and you get back 20 times as much. Now it's pretty obvious which one's going to work there. I'm comparing 2 projects here, both which have similar environmental credentials. Finally, BedZ is producing honest feedback on what did and didn't work. And we've waited for 4 years for that, and I applaud them finally that they're doing it, because then the rest of us can learn from it. Unfortunately, the lessons they're learning are ones that I already was indicating, a bit like the Stuart Milne House, that were already lessons that were learned, and that this technologically rich approach had its costs, literally, and in other ways. It was built at 4 times benchmark costs. Residents are mostly environmentalists. It expresses its technologies. And basically what it says is it costs more to build green, it's only for greenies, and it looks different. Now what that does, by doing projects like this, it marginalises the mainstream of the green agenda for another 10 years. Well, that's that funny place that costs lots of money and looks odd. You know, let's build lots more of that then. Okay? Let's contrast this with the eco-minimalist approach. Project we did in Perth in Scotland. Again, it has all the buzzwords in terms of its green credentials. This actually was a low allergy project, which I'll talk more about later on. It was built at benchmark costs. Residents are ordinary social tenants. I doubt if there's a member of Greenpeace or Friends of the Earth amongst them. And its differences are virtually unseen. And it frees you up architecturally if you're doing passive design. It's passive with an E on the end, by the way. The message it gives out is it can cost the same to build green, healthy buildings for everyone, and it doesn't have to look different. And that's what I think is the eco-minimalist approach. And that is how you build green buildings at the same cost as non-green buildings. What is the sensible thing to do? Well, actually, if we halve the demand, then already, through new standards, passive design, good housekeeping, etc., and already we're making a mammoth impact. That's another set of power stations, nuclear or otherwise, we actually don't need. And it's always, oh, we have to have this because demand will rise. Well, it's quite interesting to look at what happened over the last year and a half with the credit crunch biting. And in fact, this assumption that everything's just going to keep going and that we're not going to do anything, either in terms of technical fix or socially or anything. We can double the efficiency. The one-watt standby, better technology, lower resistances, negawatts. Then suddenly we're down dramatically in terms of what we need. We can avoid waste through better controls, better management, better behaviour. And then we can supply with low carbon, and we're left with 5%, which is easily doable with renewables. Saving the planet, reducing carbon, pretty even Stevens. Saving money in the long term, versus Reducing carbon in the short to medium term, again, Saving money in the short to medium term, insulation and draft proofing will eat it. Cost the same, realistic payback, create green jobs. Now what's interesting is a strategy of insulation and airtightness creates more jobs than a strategy of going for renewables. Low maintenance. Well, unfortunately, renewables require it. And insulation and draft proofing just kind of sits there, year after year, saving people money. Isn't it amazing? Reducing fuel poverty. Now for me, that is the crunch point. Is that you can put as much eco-bling on your building as you like. You won't take a single person out of fuel poverty. Not one. In fact, if anything, you'll make it the other way around. We really have to stop talking about our middle-class obsessions and the technical fixes, when actually these things are fixable in a much simpler way.